second. And recall, um, the one with dimensionality reduction comes higher, right? It has a higher result, so it does have um, uh, it does have some effects, right, on the scores. And then for the F1 score, I suppose it's a bit inconsistent, yeah, because the F1 score is actually like the how to what extent the we prefer recall over precision, right? And as we can see here, recall and the one with dimensionality reduction it actually performs higher, while uh, in precision, the one without dimensionality reduction performs higher, right? So I suppose we can see how it can produce yield like inconsistent results. Yeah. So like yeah, like for example, random forest, and the score is higher on the right hand side, and for yeah, well, it performs differently, right? But yeah, okay. Mm. Oh, okay. So, okay, I made a mistake here. No, no, no. Yeah, it's actually correct. Like, generally speaking, yeah. Okay, never mind. Okay, so that's that for F1 score, I suppose. Uh-huh. Okay, so let's go to AORC. Okay, so for AORC, Random Forest comes out on top for the one with dimensionality reduction, and for some odd reason, despite QDA being on top and the one without dimensionality reduction, when it uh, when we apply dimensionality reduction, it performs very well actually. Like it has quite a high score, but it actually lost to something like random forest, right? So yeah, uh, I suppose yeah. So I would say Random Forest is actually pretty consistent in terms of performance. Like even if it's not the first one, and even if it doesn't come out on top, like the one without dimensionality reduction, it comes out in second place. So it is actually still a pretty good choice. And yeah, for this one, the Random Forest is essentially like the one with the most amount of time taken to complete like the fitting time and the scoring time process, right? And yeah, the second one I suppose is the logistic regression, although this changes, right? Yeah. Okay, and generally speaking, we can see that the amount of time it takes for the fitting time and the scoring time it takes for each model in general, it decreases with dimensionality reduction. And this is pretty obvious because you consider less things, right? For when the dimensionality is reduced, and therefore uh, you take less time, right? Because it's computationally less expensive. All right, and I suppose and when we talk about the model that is most suited to be used in the case of binary classification for breast cancer detection, the thing about so like there's actually an anomaly, right, in both the with and without dimensionality reduction. In that, in precision score, the random force doesn't come on top, right? It comes out second. But the thing is, and that's actually pretty good. Like it does have a pretty good score. It just comes out second. But the thing is, in terms of breast cancer detection, the cost of having false positive is actually not that severe, but the cost of having false negatives is actually very severe. So you would actually want to try to um, prioritize, right, recall over precision. And technically, if that's the case, like we shouldn't actually use F1 score. We should actually use like a higher beta score, like for example, 2, right? And yeah, I suppose that's it. But in general, I would have to say that because of high accuracy, high recall, high AURC as well, I would say that random forest is the way to go. It's the model that we should choose, despite it having like the highest amount of time for it to have a model fitting process and a model scoring process. This is because we obviously want to prioritize like quality over performance, and provided that we do have the computational power, right? And yeah, so for the conclusion itself, yeah, this project shows the performance evaluation of supervised machine learning models with comparative study between various pattern classification algorithms for breast cancer detection. The algorithms are applied to detect breast cancer from Wisconsin breast cancer labeled dataset, and um, we conclude that random forest is actually the best tool to actually so yeah, the the random forest algorithm is the best tool algorithm to analyze and detect breast cancer, right? And with high performance of accuracy, precision, and recall, precision, recall, uh, F1 score, and AUROC, right? For future work, we definitely want to implement deep learning because it is actually a lot more exciting, um, and yeah, a lot more um, effective, I suppose. Yeah, a lot more accurate as well. And the second thing is that we can also apply other dimensionality reduction methods. Um, yeah, we can also apply other dimensionality reduction methods that uh, in order to find out which one is most suitable for the Wisconsin breast cancer data set, and then perhaps like we can uh, F2 score should also be used instead because in this particular higher okay higher beta value for F beta score should also be used instead of it should be used instead because in this particular case recall is actually prioritized than precision, right? And then what else? Yeah. Okay. Uh, okay. So for dimensional reduction, we can have that. Oh yeah, for cross validation, right? So for cross validation, we can implement what is it called? Stratified. Uh, yeah, stratified uh, cross validation, right? And stratified cross validation, stratified class. Okay, stratified cross validation, multi-fold cross validation. Since our data is actually imbalanced, though not severely skewed. And then we should also use repeated k-fold cross-validation, because like uh, the data set is actually pretty small, right? It only has uh, uh, and repeated k-fold cross-validation. Since our data set is very very small, 569 rows only, although it originally has 30 features, 30 different features. This this can be done since oh yeah, and okay, since our dataset is very small, and the the whole process is actually not computationally expensive, right? And yeah, the models are not computational. The models are actually not that computationally expensive, as shown by our fitting and scoring time. Right. So that's it for this video, and yeah, so this is the end of the sessions, and yeah, thank you so much for watching, and I hope you like it, and yeah, bye.